2014 U-value question asks us to calculate the U-value of a floor, the cost of heat loss of the floor, and the sketch involved in part C. To start the question, I draw my grid 50, 30, 30, 30 with element, conductivity, resistivity, thickness and resistance. To start filling out my table, I start with the internal floor resistance. This is the resistance of the air stopping the heat escaping into the floor. Then there is my concrete floor slab. This is a conductivity of 0.16. I input all the elements of the floor for the insulation, the DPC and so on into the conductivity because there is a symbol of a small letter K beside it in the thermal data. Next I start with my thicknesses. All thicknesses must be inputted in meters. However, all thicknesses are given in the question in millimeters. To convert from millimeters to meters, I must divide by 1000. Input all these figures into the thickness column. To calculate my resistance, there's two formulas I need to know for the exam. Resistance is equal to T over K, and my next formula is resistance is equal to R multiplied by T. Because in this particular question, there is no resistivity, therefore I'm dealing with the first formula. Resistance is equal to thickness divided by conductivity. I then add up all my resistance to give me my total resistance. The last formula I need to know for this part A of the sum is U value is equal to 1 over the total resistance. So in this case it's 1 over 7.7. This will give me a U value of 1.298 watts per meter squared degree Celsius. There's marks in the question for writing down the unit of measurement and also for writing down my three formulas. Part B of this question asks me to calculate the cost of heat loss with this floor. I start by writing my shortened formula, which I must know for an exam, which is U value multiplied by area, multiplied by the temperature difference between inside and outside, multiplied by the time in seconds that the heat is on for, multiplied by cost, divided by the calorific value of oil, which is the energy of oil, multiplied by 1000. Area must be in meters, squared, temperature difference in degrees Celsius, time must be recorded in seconds, and cost must be in euros. In this sum, the area of this room is 13 multiplied by 7, which is 91. The temperature difference between inside and outside is 14 degrees, and the time in seconds is 60 seconds multiplied by 60 minutes, multiplied by the 12 hours a day that it's on for, multiplied by the 7 days a week that it's on for, multiplied by the 39 weeks. This will give me a massive answer in seconds. All the data that I just gathered must be inputted into my formula. Take great care when putting into the calculator that you input each digit correctly and ensure that there's brackets around the top part of the formula and the bottom part of the formula to ensure the correct answer. The correct answer will be given 50 cents above and below your correct answer to get the marks in the exam, so be sure to be as accurate as you possibly can. Part C of this question asks you to calculate the best practice to stop a cold bridge near the foundation of this house. I start by drawing a strip foundation with my rising walls, and here they're looking for the insulation of the floor, the insulation of the walls, the DPC, but what they're really looking for is the vertical bit of DPC where the floor meets the wall, and also those pink blocks which are thermal blocks to stop a cold bridge. There was 80 marks for this question in the exam.